All right, number 83 on page 130 is the last, or I think it's the last one, I don't know. Asks us to prove that for any complex number, if you multiply that complex number times its conjugate, you are guaranteed to get a real number. We actually use this whenever we rationalize or realize when we take the bottom, which is imaginary, and make it real. Remember, we multiply by the conjugate to make it real. We realize it. Okay. So to do the proof, let's just start working this and prove that it's a real number. So z times z conjugate. Z is a plus bi, and the conjugate of z is a minus bi. We're just going to show that when you multiply this out, the imaginary parts go away. A squared minus abi plus abi minus b squared I squared. So the I squared, as you know, makes that a positive. So that's a squared plus b squared. And then these two components cancel each other out. So this is my result. And remember, if this is a complex number, a is a real number and b is a real number, right? Well, if a is a real number, then a squared is a real number, and if b is a real number, and b squared is a real number, and the real number system is closed under addition, meaning if you add two real numbers, you get a real number. This is a real number. So that's it. That's the proof. It may not feel real fancy or even really all that accurate, or legit, but it is. And that's why we multiply by the conjugate in order to make the bottom number of a fraction that is imaginary real.